All right. Good morning, afternoon, or evening, everyone. Looking at the participants, it is a kind of a time zone neutral event we're having here. My name is Mark. I'll be your moderator for today. And let's start because, well, just like with an online class, those should also start on time. First, let me start by mentioning a few practical things so we can make the most out of this hour. We bet there are questions. These can be asked through the chat box, and might do a few questions after a speaker session, and the rest we'll do at the end. And of course, we'll leave our contact details so you can reach out with any questions that come to mind later. You can also move the video feed, and you can dock it as well. There's a picture how to do that. All right, this is the agenda. I think I can be brief here. First, I'll explain briefly what the math problem is we've been busy with. Then there are two interesting speakers. Then I'll take over again, and then we'll have the Q&A set. And well, we promised that we will try to make sure that you have some interesting takeouts of this webinar. The presenting teachers will share both research findings as well as tips and tricks straight out of the lecture room. And then I will take over again, and you get to see some interactive online maths in action. All right, the math problem. Well, first, let us define what we actually mean with the maths problem and why it is a problem. And of course, literally speaking, it is the problem that students have with math. But more specific, it is the mathematical ability and their preparedness to study for it. And that is declining, and particularly in related academic subjects like engineering, economics, biology. And so for teachers, it is the issue of having to teach math to large groups of first-year students, and they're going to go for non-math majors in college or uni. These students are not particularly good at math. They're not particularly liking it because they chose a non-math major. And they even may suffer from math anxiety. And teachers only get a limited time, like a trimester, semester, or sometimes even a half semester, to get everybody on the same desired level. And that level being that math knowledge that is a good foundation and success factor for completing the rest of your studies. And the challenge to deliver this type is called service education. It was already there before COVID, due to the huge class sizes and the limited options to provide the personalized attention to students. But since recent months, it's more challenging than ever. There are two main reasons. Well, first, apart from the fewer classes they had in high school, in quite a few countries, high school central exams were cancelled altogether, and the higher enrollment because of these cancelled exams, and the fact that many students, they don't take a gap year anymore. So the new influx of college or uni students, it's both higher and it's more heterogeneous than ever before. And on top of that, in many countries, online teaching is still the status quo right now, and it's uncertain what the teaching is going to look like the rest of the year, or maybe even years. So how are you going to give that targeted attention to those students who actually need it most in a face-to-face or mask-to-mask setting, a fully online setting, or any blended or hybrid mode in between? Well, so that was kind of setting the stage here, but now more interesting, for the coming 30 minutes or so, we will hear from two teachers firsthand how they embraced digital tools and were able to step up their online game also in these trying times. And if you have any questions, like so that you can type them on the bottom right in the chat box. So I'll give the floor to Dirk from Maastricht University. Dirk actually uses Bolster Academy under its Dutch brand name, Sowiso. Yeah.
Okay, thanks, Marc. Welcome to this introduction. I hope you can hear all of me. So I'm in fact one of the early adopters of the system, since in the Netherlands, already about 15 years ago, there were a lot of initiatives to raise the level of mathematics proficiency of students. And we joined those initiatives and started using Sowiso, so the Bolster Academy, about 15 years ago. A typical situation where I teach mathematics is I teach students in the introductory mathematics and statistics course, so the very first course they see when they enter university. And my public is a highly international group of students. So at the moment we have 75% international students against only 25% local students. Last year, I will discuss some experiences of last year, but this year we have even 200 students more than last year. So we have a class of nearly 1,300 students. And the other facet of heterogeneity is that the prior education of those students is very, very different. It's a very heterogeneous group. Some of them are at an AP/BC level. About 30% of them are, but most of them are at much lower levels. And in most Anglo-Saxon countries, one would start with streaming such courses, but in the European context, such streaming is not allowed even. National regulations in nearly all European countries prohibit streaming and tell that all students from different backgrounds need to do the same exam and need to go through the same course. And so that's the major problem we have, as Marc already addressed. It's a problem of heterogeneity, but that problem is also because of the international population of the students. So we started already 15 years ago with hybrid education. The face-to-face component is problem-based learning. The technology component is 2 digital learning labs, where we use Bolster Academy for the mathematics part, and we use the well-known Pearson MyStatLab environment for the statistics education. So we're using 2 different learning labs. My reporting is now on everything on the Bolster Academy, because although the Pearson learning labs are fine, the big problem is you cannot get a lot of data from them. And in order to optimize learning, I really need good data from the learning environment in order to optimize the learning of my students. One of these things which is of interest of me is what are the typical scaffolds which are available in the learning tool, and how can we help students and how can we diagnose students, and as we see how they are learning, using the learning scaffolds. And in the literature, one typically sees that there are different types of scaffolds and also different student support approaches. One of them being the so-called tutored problem solving, where you help students in problem solving by providing help, often called hints. The untutored problem solving, where you demand students to solve problems independently. And then a well-known other approach is the worked-out example approach, where you first offer worked-out examples to the students, let the students study those worked-out examples, and next ask students to solve problems themselves. And so these are different scaffolding approaches well known in the literature. And if you look at the Bolster Academy, you can exactly see all of these approaches, because students are offered mathematical problems, as for instance over here, one of the problems students should be able to solve in my class. As they have tried to solve the problem, they have the options over here. Check, which is the so-called untutored problem solving. They solve the problem without any hints, and then just check if they were able to do that in the correct way. Then the hint is the tutored problem solving approach, where in some steps they can ask for hints in order to go over an obstacle and go to the correct solution. And if they have little idea about how to solve this exercise, they can choose for the solution option offered over here, which in fact provides a worked example. Those three described options in the previous page, Bolster Academy gives a fourth option, which is the theory page, where students goes back to the explanation of a theory and then tries to solve the problem. And so, very short, because it's probably rather obvious, these are the several options. So here you can ask for a hint, and the hint is then provided over here as a kind of first step in the solution, and then the students tries to solve the problem with that hint. The theory page gives you a description of the theory behind this topic of visualizing bivariate functions. The solution page is what's called solution page in the Bolster Academy, which is the worked out example. So here it gives a worked out example for a specific problem over here. And after studying this worked out examples, the student is asked to redo the problem. Through parameterization, the student gets a similar but not identical problem and tries to solve that independently. And so working with this tool and having very detailed timestamp data of what students are doing in this digital learning environment, we were interested to see the following question. First, how do students time their learning? And second, what learning scaffolds are they using in their learning? And to give some more details on these, in terms of timing, there are in fact three important events in our educational schedule. We have these so-called problem-based learning sessions, these weekly tutorial sessions. And first of all, we expect students to be prepared for these tutorial sessions so that they have some knowledge using in their discussions in these PBL sessions. Next, 2 weeks later or 1 week later, we will have some quiz sessions, which will students allow bonus points, and then there is the final exam. So knowing those three important sessions, we can in fact break down the preparation of students in 3 learning phases. Everything in green over here is the preparation students do for their tutorial session. Everything in orange is what the preparation students do for their quiz sessions, and everything in red is what students do in the preparation of their final exam sessions. So this is how you can make break for the timing. Now, if we are looking at those timing issues and how students work in the learning environment, we see that most learning takes place, or most practicing in fact takes place, in the second phase. So the blue, the red, and the green are in fact indicating how much students practice. Those are cumulative. So the blue, and then this is extra in the red one, and then this is again extra in the green one. So those are cumulative in terms of their mastery. Most of the mastery happens in the second learning phase. In the third learning phase, there's only little added. And in the first learning phase, for us, the most important learning phase, only 27% is mastered of the total topics. If we're looking at the several learning scaffolds, we see another picture where, first of all, what is clear that students not very often use the option of hints. So if we compare the hints with the solutions and the attempts, we see that there are relatively little uses of hints, much more of the solutions out of these attempts. So you can compare those solutions with the total attempts, and you can see that basically in about 1/3 of the attempts, students are using the worked out examples. The next thing which we did is try to design several student profiles. And we did that with a statistical technique called clustering, and we based those clustering on the variables given over here. And the outcome is that we find, in fact, 6 different clusters of students who are relative inactive, low activity, high activity, focusing on the quiz preparation, high activity focus on tutorial session preparation, extreme high activity, and students with high prior knowledge. Those were the 6 clusters we would discover. And those 6 clusters distinguish quite clearly in terms of all kind of trace data we get from the Sowiso or the Bolster Academy system. In terms of attempts, you see that there is this group of students, a relatively large group of students, who is extremely active. Both active in terms of total attempt, also very active in terms of looking at worked out examples, however less active in terms of the hints. The group which is most active in terms of the using hints are the students with the highest levels of higher education. So apparently we learned that the hints are especially useful for students with a thorough background, but less useful for students who have less background in learning mathematics. We also see that there are huge differences in timing of the learning. We see that especially these 3 groups of students time their learning the way we would hope that most students would time the learning, that is in the preparation of the tutorial group sessions, whereas much more students time their learning in the second phase, especially groups, the students in the first 3 groups have the majority of the attempts in the second learning phase rather than the first learning phase. There are a few students who are focusing on the exam, preparing the exam, which is in our eyes a positive thing, because they already have practiced a lot for the tutorial sessions and the quizzes and don't need to practice anymore for the exams. In terms of timings of the attempts, we see again these large differences, and these are the attempts. And on the next slide, because I will try to go somewhat faster, we will see, I don't know. So these are not so much the attempts, the title is wrong over. These are the examples and the hints. And you can see over here that in terms of the examples, students use examples in a different way. There's a group of students, and especially this group of students who is giving the proper learning approach, who is using the examples as a preparation for the quiz sessions, whereas other students use examples much more as a preparation of exam sessions. Okay, then you see a clear relationship with performance, although the differences are not as large as the differences in activity. But we will see that especially in the math exam and math quizzes, this dark blue group comes out best. We see a relationship with learning dispositions, and especially the relationship with, I will jump to the next slide, where we see relationship with achievement emotions. And we see, for instance, that the group of students with very, very high activity is partly explained by their learning emotions, but because that's the group of students which have anxiety towards mathematics, who lack enjoyment in doing mathematics, and also have some feeling of hopelessness. And so the attractive thing is combining these trace data we get from the Bolster Academy with some background data we have from students, and because we get this data from surveys, is that you can understand the behavior of students in these learning environments. So that brings me to the finalizing discussion and conclusions. We find different profiles of students, thanks to the fact that we have a large group. This cluster analysis brings us different profiles. We see large differences in timing of learning, as well as the way students use these different scaffolds, both the worked examples at the one side and the hints at the other side. We find relationships with academic performance, it's somewhat weaker, and we find strong relationship with learning dispositions, which can help in terms of educational interventions to see what students need more help in order to overcome their anxiety. So I guess this environment, which provides such rich data, not only helps students in practicing, but also helps the teachers who are seeing very large classes to get proper learning feedback to the students. Okay, Mark, this was my contribution.
All right. Thanks a lot, Dirk. For me, it's just short because I will be introducing the next presenter. So Dirk's story was more research inspired, and Fleur, another teacher, she focuses more on the teaching in the presentation. This one is actually pre-recorded because she couldn't be here in person, but it's just as interesting.
Hello, everyone. My name is Fleur Zeldenrust. I am an assistant professor at the Radboud University, the Donders Institute, in particular the Department of Neurophysiology. So I am a computational neuroscientist, and I will talk today here about the teaching that I do, and in particular the first year course I give for biology students, which is called Mathematics for Biologists, not surprisingly. I will quickly explain a few challenges that we had with this course and how we solved them, and I hope that will help you all with designing online teaching. Firstly, I will discuss with you the how we set up the course and the challenges we had there, and in particular the kind of diverse backgrounds that the students have. And then we will discuss how we went online last April due to the Corona crisis and the challenges we had there. So to begin, the course is for about 100 to 140 students. And these students are biology students, so mathematics is typically not their first priority in secondary school. For some it is, but for most it isn't. So they have a very diverse background. So some had, in the Dutch system, mathematics A, some had mathematics B, and internationally we also have a quite reasonable group of international students. There's also a huge difference in the background that they have in mathematics. So when I started designing this course, when I took it over in April 2019, I was asking myself the question, how do I keep all those students aboard? Because you don't want to make it too hard for the ones that don't have a lot of mathematics background, but you do want to keep it interesting for the ones that do, that might want to go on with it. So how do we do that? Firstly, we started with the content. We started with a bit of preliminary material and two preliminary tests. So we basically, before the course started, we said, okay, this is kind of the level. We gave them two tests. This is the level that we expect you to have. And if you do the test, you can do it as much as you like, but I expect you to understand this. And if you don't, here is some material you can practice with. So this typically included things like exponents and fractions and these kind of things. Now, what we did during the course is we had for the course was a typical kind of first year mathematics course. So it includes integration and differentiation and introductions to differential equations. Well, especially the differentiation and the integration, some students have done already. So for them, I provided some extra material and some biology examples that they can practice with. So for instance, here we see the week was divided in the course was divided in 8 weeks. And every week had a topic like basic math or differentiation. And here you see, for instance, in one of the basic math, we also give some biology examples, also for motivation, like especially for biology students, this is important. Why am I learning about these math techniques? Well, because you might need them, for instance, here in the hospital. Then we thought also the way of studying and the pace at which students are studying is very different from student to student, because some need much more support, others are already a bit further, so they're quite independent. So how to allow for students so that they can study in their own pace and in their own preferred way? Well, for this we had a tutor who was actually also a high school teacher. So every week we had one entire Wednesday. So basically every day started with a tutor hour, where he could really go with the students that had a hard time, that didn't have a lot of background to mathematics, and he went through all the materials. And then the day had normal lectures, and it had tutorials. And the difference with the tutorial is that these were supervised by assistants, so typically third or fourth year students. And every tutorial, the attendance was obligatory, but they had to do at the beginning a diagnostic test. And if they showed to the assistants that they had done the test and passed it, they could go. So for the smart students, they just basically had to show up and then do the test. And if they showed they could do it, they were free for the rest of the day. Whereas for the other students, there was really a chance there again for one-to-one interactions and quiet explanations. And the assistant would work around while the students would work on the materials. And also the materials, because they're all randomized, you could keep on practicing the ones that you find hard, or you could skip the ones that you find easy. And the diagnostic test was also very good for that, because the students could really see, okay, what part of the content of this week do I understand already, and which one do I have to practice a bit more with. And then during the rest of the week, they had also ways of contacting us. That's basically during the Sowiso forum. And I also always, I find that important as a teacher, give an opportunity for anonymous contact. So for instance, during the lectures, I did that with an app, with Google Slides. You can use that, and then people can, with a text message, can send basically anonymous comments. And of course, there's always a lot of in-person contact, both through the lectures and the tutorials and the tutor hour. So that worked quite well. Students were happy with it. We were evaluated well by the students, which is a little bit uncommon for mathematics courses in biology. So we were very happy. So we were, improving, we're making some minor improvements, and we're going to do the same thing next year, April 2020. But then the Corona crisis hit. So as many of you will probably have experienced, that meant that all of a sudden everything had to be online. So, fortunately, we had everything in Sowiso in online already. All the materials were already online. So my first worry was basically, okay, so when I cannot actually meet with them, if there's no lectures, no tutorials, how do I keep in contact with my students, and how do I keep track of them? How do I see, if they're not stopping or having troubles that they might not be able to say to me? Like I said, the good part was that all the material basically was already in Sowiso, and all my lectures in 2019 were videotaped, so they were still online. So I could just transfer them to that year. That was a lucky part. So my main focus first was, okay, I want to keep in contact with the students. So basically every normal contact hour that we had was transferred to online. So the tutor hour with the high school teacher went online to the virtual classroom, which is an online meeting app that we have at the university. The lectures turned into live Q&A sessions. So I basically told them, you can watch the video, but I'm online here all the time. You can ask me any question at any time, and I will explain it to you. And of course, I realized that then to explain mathematics, you need to write. And normally I do that on a blackboard or on a whiteboard, but of course, with a computer, that's different. So I bought myself one of those pens and writing tablets. So I could write and make notes and really make explanations, do derivations step by step online in the virtual classroom. But then, of course, every question you have to ask, both in the tutor hour and in the lecture hour, is with the whole class. And not every student likes that. Some of them are a bit more shy. So therefore, the tutorial sessions were really set into breakout rooms. So basically, every student was in a tutorial group with an assistant, and they could really, during these lectures in a breakout room, ask one-to-one questions and get really one-to-one explanations if they wanted to. Also, during the whole time, there was a very active use of the Sowiso forum. The assistants were on there as well. So often, students got, like, within half an hour to 2 hours, they got answers to their questions, because I was very happy with that. My assistants were very happy. And I created an anonymous contact form. So if they had any feedback or any things that they would like to share with me that they didn't want to do with a name attached to it, they could do that. I just made an anonymous Google form so they could contact me anonymously. So here I just wanted to show you a little example of how this went in the virtual classroom. So this is basically what they would see. This is a Google Jamboard. There you can write if you have one of those tablets. And I'm here. You can see here I am explaining a question. So I'm really doing it step by step. I would write this, and they would see it real time as I write it. So okay, this is an example of logistic growth. This is the general solution. Now we have to calculate C, and so on. I would do this really. I would write this down as I was speaking. So really as if you're writing on a blackboard. So that was basically what our lectures were like. The other thing is, of course, that we wanted to keep track of the students to make sure that they don't. I mean, it's really strange that when students are not on campus anymore, you don't see them. So also, if they might have any other problems, we can lose them. So that's basically what I used now the diagnostic test for. I said, okay, the diagnostic test is now, it's obligatory that you pass it every week. Although I didn't tell them that, but there were no real consequences if they didn't pass it. They had 3 attempts. They had to have 75% correct. But, if they had any trouble, if they would just contact me, they would get extra attempts or an extension or whatever. It was for me a reason to keep track of them. So if they would not make the test, or if they would fail them, then they wouldn't contact me, I would contact them and say, like, hey, I see that you failed the test. Are you doing okay? Is there anything I can help you with? And this way, I often got into conversations with students to see what was going on. And sometimes problems surfaced that I didn't think about. For instance, one student turned out not to have a laptop. So she had to share a laptop with one of her study mates, and it wasn't just available that often. There was another student that had a hard time focusing because he had a hard time focusing on his own in his room. So we talked about that. Some of them had, international students went back home, so they had to move country again. All these things we could discuss, and I could keep in contact with them this way through the weekly test. Might sound weird, but it was a point of contact, a reason to contact them and then start a conversation. So that worked really well. Then, of course, we had to do an exam. And the year we were doing the exam on campus, we did it already electronically, but we did it on site. So they had to go into a classroom, and they had to do the test there on a computer, so that we would really minimize the chances of fraud. But of course, now they had to do it at home. So I had a long set of discussions, or with very supportive discussions with the team at the Radboud University that was doing the support for electronic teaching. And in the end, we decided not to use proctoring. Proctoring, as you know, is you have these external companies that see if students are not doing fraudulent things. Well, first of all, I think, and I was also contacted about this by my students, there are real privacy issues with proctoring. They have to install software that then gets access to all your files on your computer, retracts who knows what, then stores it in databases that are not in Europe, so European law doesn't apply. They have access to the camera. There's some real privacy issues there that I also share with the students. I wouldn't want to install such software on my computer. So I really agree with them on that. Some students also said that they felt very uncomfortable. They found it very stressful if they had the feeling that someone is watching them all the time. And then the third thing is that for mathematics, the teaching that I do, I allow them to use a calculator and I allow them to use a formula sheet. The problem with that is that they're not watching the screen all the time, but they're watching, the formula sheet or the calculator. So it is, and most of these proctoring softwares are based on eye tracking. So that doesn't work. And also the experience in our university is that the proctoring gets way too many alarms. So there's way too many signs of fraud when there's no one there, no fraud there. So for all of that, I decided not to use proctoring. But of course, we still have to prevent fraud as much as possible. And some other issues with electronic exams are the automatic correction. And that is with mathematics, normally you have a consistency rule. Like if you in your derivation in the beginning make a mistake, but you do that consistently, then you want to give points for the other steps that you made. And the software is not always capable of doing that. So that's also a thing. There's also a full screen mode, but I will get back to that. So one of the easiest solutions for this, for actually the first 2 points, both for the automatic correction and the lack of proctoring, is that students had to upload notes. We did that already last year for the exam, is that they of course they give their answers in the electronic program, but they do their derivations normally by hand. So they had to hand those in when they were doing the exam on the campus. But now we said, okay, you have to upload them. So Sowiso has a function for that. So for every question, I want to see some notes. It can't just be a small comment. I could just see it from the general form or something, but just that that I can see your reasoning. So that had actually 3 advantages. One is, of course, the fraud prevention, because it's very hard to have a correct answer with the correct derivation that you just found on the internet. There's 2 other advantages. One is that they learn from it. So they had to, I made them check their own exams. So basically after they did their exam, and I did some small checks, then I just gave them their results and also what was wrong and what was correct, so they could see that and they could compare that with their own notes, which means that they really learned from the exam. They saw what they did wrong and at what step it went wrong. And for that, they could come back. We had assigned a moment for exam correction, and if they said, okay, I think I still deserve some points for this question, they could come to me. And then they could compare their notes with the answer, and then sometimes say, yeah, okay, the program said that this was wrong, but you did 2 out of 3 steps good, so I can still give you 2 out of 3 points for this. With this, they also really had an incentive to look at their own exam and to look at their own mistakes. So I think this worked really well. Now, other things that we use to prevent fraud is randomizing the order of questions, and inside the question randomize the numbers in the questions. So it would be really hard to, through WhatsApp or something, do the questions together with other students, because they all basically had other questions in a different order. Now, a last thing is, of course, a real smart student could use something like Wolfram Alpha on the internet. Still, they would have to think of a derivation to write down, but they could do something with Wolfram Alpha on the internet. That is not completely unavoidable. But then if you're smart enough to do that, then I think you also pass the exam, more or less. We made the course unavailable, but you could in theory make this impossible by having a full screen mode. However, Sowiso advised me against doing that, because at this moment the full screen mode was too buggy for outside of classroom use. So it worked for classroom use, but not for individual use. So we decided in the end to accept this as not being possible at this moment. And then one last thing that we did, which I thought was actually a lot of fun, because I learned a lot from it myself. I was like, okay, I'm teaching mathematics to biology students. So what is a better example for explaining differential equations to biology students than epidemiology. Of course, during the corona crisis, this was a lot of fun. So I made a lot of, every week basically started with an example from epidemiology, where I really explained things like the R and the R0 that we're hearing all the time on the news, and having all these kind of exponential growth, and the SIR model, which is apparently one of the most used models, simple models for calculating these. So yeah, I mean, that's also, I found that a big advantage of using these electronic types of teaching is that I could easily fit this in, and I thought it was a great occasion to explain all these kind of models and the techniques that we use in mathematics. The one thing I did say is that it was not obligatory material, because I thought maybe, we were in Nijmegen, we are close to the south of the Netherlands where the corona crisis started. So maybe for some students it could, I don't know that, but it could have been personal. So I said, okay, if this is emotional to you, you can skip this part. For the other ones that find it very interesting, here is why we do mathematics, because we hear now all at the news that we're making models of how the disease spreads. What do these models look like? Well, you can basically make the most simple ones. You can make them now after this course. So I thought in the end it was a great occasion to explain mathematics to biologists. Contact me if you want any of this content, because I'm more than happy to share this with anyone. Yeah, and with that, I would like to end this presentation by me. Feel free to contact me. I also have to give special thanks to André Heck and Jana Virastekova, André Heck at the University of Amsterdam and Jana at the Radboud University, because we really, the three of us, we share lots of content and materials and experience of how this kind of teaching is. André Heck teaches biology students and psychobiology students at the University of Amsterdam. Jana teaches mathematics for economy students and management students, but we really share a lot of our content and our techniques for these kind of courses, because in the end, the basic course in mathematics is a basic course in mathematics. But please contact me if you have any questions or any comments. I'm more than happy to share my experience.
We're gonna take a look at some of the tools in action, what the teachers have been talking about. So for that, I will share my screen. And let me see. 1 second. There we go. So you can now see my screen. This is our tool. There are more tools out there, of course, but I'm going to show you this one. This is what this is an interactive and digital textbook. We have a lot of other Bachelor 1 and Bachelor 2 content, but I will show you some examples of this, what we call a basic math course, which is really a foundation math 101-something course. So you can see that it's just a digital book with chapters. If you open a chapter, there are subchapters, and you can click on a theory page. There's some of the things you already heard from the teacher. So this is what a simple theory page looks like. This is very basic stuff, but I want to show you that one of the main advantages, of course, of doing something online, digital, is that you can add a lot of interactivity to it, and especially for the types of students, the non-maths majors, they don't benefit by throwing a definition or a mathematical formula at them right away. So they like to have a more visual approach. I'm going to show you a few other examples. So geometry is also an interesting thing, of course. So maybe this is a cool one to show you. Yeah, so there's a lot of this is actually more a bit of an applied subject. So once again, a lot of interactivity. This doesn't evaluate anything, but it's just for the student to get a feel for it. there are a lot of examples here that they can look at. Orbit, so a bit of physics as well here. Maybe one last theory page example. So this course actually ends with integration. It is, as I was saying, it's like a first year college maths course, or it's also used as a summer course for university prep course to get everybody up to speed. So there's 3D plotting here as well. And actually, you can take a look, for example, we don't show everything right away to the students. So mathematical proof like this, most students, well, a regular student would say, I don't need that for the exam. I'm not going to take a look at it. But the more eager students, they can find that extra information if they want. And so we always work with these kind of step-by-step worked out solutions. And these examples are also good to show you, because if I revisit this same example, you can see that the parameters have changed, and hence also the worked out solution, but the steps, the procedure stays the same. So students can revisit these types of examples over and over again. So that was a bit of theory. More interestingly, let's show you an example of a question. So it's a very simple example, but it serves the purpose of what I want to show here. So this is what a typical exercise look like in our system. So you have to make sure that the inputting of it in a digital tool very much resembles how you would input math in real life on a pen and paper. So that's why we have this visual input editor here. So you can see that there are many mathematical domains that we cover. So for this subject, this is of course an overkill, but it serves the purpose to show you that we cover those domains. Also physics support, so we accept units. And a regular keyboard, by the way, because it also works on your tablet or smartphone. But I will use my hardware keyboard in this instance because it's a simple example. So let's start to answer it. I used copy paste. That also works. So, and the interesting thing is that we always try to give you some feedback on what you're doing and try to guide you to the correct answer. Here there's actually a glossary here as well, so you can look up some terms. Well, in this case, literally a term. You can ask for hints. So let's do that. Let's make a mistake. So I think I read the hint correct, and I'm moving the term from the left to the right hand side, but I'm doing it not in the correct manner. Then the system also sees not only that I made the mistake here, but also what that mistake is. So let's correct that. So I should have added. So once again, I get some feedback. Let's continue. Still not there. So I did ask for another hint, as you can see, and it's correct. Yeah. So here I am. You can ask for the formal step-by-step solution here as well. But this is, of course, what the students really like. The step-by-step feedback that they get. The students say, this is exactly what the teacher would do if he was looking over my shoulder, and I don't know where to start. So you get really taken by the hand in that sense, and it's personalized. Now, if a student now wants to revisit the example once again, you can repeat it with different parameters, and of course, if the student answers x equals -9/2 in one go, it's also correct. It doesn't stop you if you know the answer already. There was also a mention of the forum by the teachers. So that's a thing that I also want to show you. So if you do get stuck as a student still, there's the option to ask help here. And the forum really is like a digital classroom. So I can ask, y is x minus 9/2. Yeah, it's a silly question. Actually, you can also use the same input editor here, or you can even draw things. Sorry. So now I post this on the forum, and the good thing about the forum is that it's context rich, because I'm now accessing the forum right away, and I'm scrolling down. So you not only see the question of the student, but you also see all the answer attempts that the student gave and the feedback that the student got from the system. So you not only see the problem of the student, but you also see the process leading to that problem. So in that sense, you can answer right away here. So students really appreciate it if they're working from home and they gotta trust a digital tool to help them. And if they still get stuck, then there's still the option to get a bit of really teacher-student interaction. So that was a very, very quick dive into the tool itself, and maybe now there were a few last things here about the learning analytics. Actually, so there's also rich reporting. So the story of Dirk actually did prove that. So he got a lot of learning analytics out of it, and as you can see in these slides, that sorry, next slide, please. Yeah, so this is all anonymized, so this is not real data, but this gives you a view that the teacher can identify like red flags or which subjects need extra attention, and you can use this rich learning analytics to use the time that you have in class in a more efficient way. And help you get the correct diagnosis of your students. So, yeah, well, this was it for now. We'll leave with our contact information on the screen, so you can always drop us a line over there. We can set you up with a demo account if you're interested in learning more about the tool. And that's it then for now. So I want to thank you all for joining us, and enjoy the rest of your day. Goodbye.